All right, good evening, everyone. So I've done this sketch to sort of explain just a lunar eclipse and also to be able to assist with the understanding of the Selenelion eclipse. Because I was having that conversation with Ken and with Stone and with Brian. And I mean, this video, I'm hoping that Ken will watch and sort of understand and be able to at least move forward from his confusion about why the shadow goes in particular directions. So for starters, as you can see here, I've drawn a blue line straight down the center. The whole idea is that if the sun is where we are and the earth is in the way, then the moon would be directly in alignment, and that's how an eclipse happens in the first place, right? Now, I've drawn over here that the moon enters from this side, right? And the moon exits on this side. And this is in from the point of frame that this is where the North Pole is, right? So as you can see, I've done a little sketch here of, Americas and South America, right? And so this is looking at the Earth front on with the day side facing us, right? And the night side at the back. Right? The night side is at the tail end of the planet. And so all the sun from the light is going straight towards the planet from this direction. And as you can see, when you move on, the moon is behind and it is moving from this side into this area and then out. Okay. Now, some of these lines, what we've got here. So what we've got here, we've got two lines here. Because the sun is bigger than the earth, naturally, geometrically, there will always be a bit of an overlap of light that comes around from one side and kind of sort of takes away some of the shadow on the left and takes away some of the shadow on the right. This happens, anywhere. You see it in the sporting matches. You see it when some players on the field, they have like four shadows, and most of those shadows are all a bit dim because those four shadows, if they've got four lights in the stadium, right, that shadow is only one, quarter of the true shadow that would happen because the other four lights are shining in the opposite direction and brightening up those shadows, right? So that's what the penumbra is. The penumbra is the part of there is shadow happening, but there is other light which is adding to it, which is taking the shadow away. Now the umbra, the one right at the back, that's the absolute best case scenario for a shadow, right? So in this umbra is where absolutely no light comes through. But not technically. That's the thing. So not technically. So because of the way that sunsets and sunrises happen, you get a little bit of an orange tinge, right? And that is most of the light bending around and then sort of displacing itself from the white light. So just like the way a rainbow works and the way a sunset works, the light sort of twists and bends the harder it has to turn around a corner. And that means that the orange kind of peels out of the white light and it will bend around and go around to the back. So that sunset and sunrise light that is red will peel around the back and give a bit of a glaze of red over the back of this eclipse. And that's why they call it the blood moon. Because when the moon is in the direct center of the Earth's shadow, and as you can see here, I know that there's lines going on here and there's circles, but what I'm trying to show with this bigger circle is that this is roughly the umbra of the Earth's shadow. All right? And the blood moon is when it's in the dead center, and that's when the sunset and sunrise light, the orange light, comes through and makes the moon a reddish tinge, right? So that's why it becomes red. Now, one thing I did try to explain to the guys, right, is that geometrically, if an observer is more than 500 meters above sea level, they can see that both the sun and the moon without the need to use, a wild card of refraction. Because the thing is, right, if you're very, very close to the surface, you're down at sea level, right, it's obviously a little bit more trickier to see both the sun and the moon in one hit. It's trickier, right? But with the way light bends, it does make it sort of more possible, right? But it does make it tricky. But as you know, if you go higher and higher and higher and higher, naturally the angle that you see in both directions peels down. That's kind of what I've shown here. So if you go higher, you can look down lower on this side and you can look down lower on that side. It increases your 180 degree of vision to like 185 or 190 degrees of vision. So you'll be able to see further down that way, further down that way, and you'll be able to see more, right? So if you increase your height, you will get to a better vantage point. You'll be able to see back towards the sun better, and you'll be able to see back towards the moon better, right? And that is one way that we can eliminate the need for refraction. Minimum 500 meters. And I mean, 500 meters is right on the line. If you go to 1,000, you're all good. And you've got to be in the right position. So let's say you're on a mountaintop. You want the sea to be on both sides of that mountain. If you've got more mountains off in the distance, it's gonna break that, because obviously those other mountains are getting in the way. It's going to change the dynamics of your position, and it's not going to come out perfect. But if you have that perfect situation where you have an ocean on both sides of a mountain, right, and if you are greater than 500 meters high, then you should be able to see them both with clear vision, no refraction. So if refraction can be eliminated from this equation. Now, the problem with the Selenelion, right, is that everyone calls it the impossible eclipse, but it happens, doesn't it? Every single time a lunar eclipse happens, someone discovers a Selenelion eclipse. So that means it's not impossible by those terms. The fact that it exists means that it is not impossible. What people say they believe it's impossible to be, right, is geometrically they don't understand. That's essentially what it is. Now, the key is, right, is that it's all about where you are on the Earth. So Selenelions can only be seen at either an area where the sun's setting or sun rising, right? So it's at the terminator lines of the Earth, where there's a shift from the dark to the light. So you must be on those extreme edges, right, to be able to be in the area for a Selenelion eclipse, right? Now, this Earth, as you can see, I'll put the arrows here, it rotates in this direction, right? So as things twist that way, right, you'll get your sunset off to the you might not understand it because it's going this way, but like you see a sunset to the west because you got to imagine the USA goes over to here and then it peels away around to the back. So then when the USA is over here, they see a sunset to the west, okay? And when the USA comes back around over here, right, then what you'll see is New York will come up first and they'll see the sun rise to the east. So you can see generally that this direction of rotation is correct. So the rotation of this Earth is this way, right? Now, when the person is in the sun setting location, they are moving from this day side here around to the night side, right? And so that basically means that as they are going this way, the sun is slowly grinding down. It's setting down, right? But it also means that the moon is rising up. So if you're on the sunset side, right, for that split second when you look back and you see the sun at this direction and you see the moon at that direction, you will look towards it, right? As you can see here, you will look towards this direction. And when the moon is going this way, the shadow will be on the bottom, okay? The light part will be on top, the shadow will be on the bottom, and then it will go down into a red moon Only the thing is that the moon is always continuing to go up, because this person is rotating that way. That is going up, 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 up. The moon is rising, right? So what this person on the sunset is seeing, they're seeing the moon rise in position, but they're seeing the moon go down into the shadow and then pop out of the bottom of the shadow. Okay, done. The sunset eclipses make sense to flat earthers. It's the morning side which confuses them. It's the morning side which they don't think works and they don't understand. So let's explain how the morning side works. So if we've got a position where we don't need to worry about refraction, we're up high enough, we're 1,000 meters up, and we've got perfect view from both left and right, and we can see the sun. Now, because the Earth is rotating this way, you're on the night side and you are getting closer and closer to that terminator line and then into the day, right? So you're going from night to day. Simple? Now, because it's rotating this way, that means that the sun will be rising like this, up towards the observer. But it means that because you're over here in the middle of the night, right, that means that the moon is very, very, very easily visible before the Selenelion is ready. It's easily visible. So the moon, as you come around this direction, is setting, right? But when you look from this perspective, right, and you look out towards the moon is moving upwards into the shadow. It's moving upwards into the shadow. And then it continues to move upwards to the blood moon. Now, the catch is with Selenelion, because a sunset and a sunrise only takes a few minutes. It only takes a few minutes. This eclipse happens over the course of hours. It takes like 5 hours to go from penumbra to penumbra. And it takes like about 1 or 2 hours or something like that to go through the umbra. So the Selenelion technically is only really valid for when it's dead in the middle. That's with the blood moon. So a Selenelion is when they see the blood moon. And that's why you see on all those images, when they show the moon red. They don't show the moon with a half cupping of light and half dark. That's not what a Selenelion is. A Selenelion is when it's in the center. It's when it's dead straight. It's when it's perfect. Because this is not a perfect eclipse. That is not a perfect eclipse. That's the perfect lunar eclipse right in the center, right? But so if you basically are in a position to see slightly different things, right? That means you're not quite at the Selenelion, right? So if you're half an hour into the nighttime before sunrise, and you start seeing the moon moving up into this shadow and the dark spot happening there, yes, you're seeing the partial eclipse happening, but you're not yet at the Selenelion. All right? You're only at the Selenelion once this moves up into the red zone, and once you're at that perfect sunrise sunset part. So when you hit sunrise, boom, it's like 6:01 a.m., right? And the sun has just started to breach above, and you look back and you see it red. That's when the Selenelion has happened. Anything before that is just regular lunar eclipse events. That's just regular stuff. Because a person who's deep in the middle of the night here, they look up here, they see the moon going into the dark pot. They see it go into the blood, and then they see it pop out, and they don't see anything to do with sunrises or sunsets whatsoever. So if you're deep in the middle of the night, it is just a regular lunar eclipse, just regular. It's only Selenelion when you actually strike sunset or strike sunset here, sunrise there. All right, so from this perspective of the moon, when it comes to the sunrise for the morning, the moon is in a setting position, right? Which means that the moon is going downwards. But the shadow is going upwards, right? So the moon is going up and cupping into the shadow, and then it goes into the part there, and then it bursts at the top. But the thing about Selenelion, right, is because it's those certain minutes where you have the red moon that way and the sunset this way. As soon as the sunset is fully up, the moon's already set. It's like 2-3 minutes later, it should be completely set. It should be gone. So a person who's in the sunrise location should not see this. If they see this, then they're still kind of around here. They're not quite at a full sun. They're not quite at the full Selenelion, right? So anyone who's on the morning side and who sees it burst out at the very, very tail end, they were not at the Selenelion location at all. So yeah, hopefully everyone can understand the way Selenelion works. It's all about which side, if you're on the sunset or sunrise location, and whether or not you've got a good vantage point to be able to look back and see the whole thing take place. So like I was saying with the sunrise there, if you're at a sunset location and you don't see, the moon hasn't risen yet, and you don't see this, then that means that you may not have been at the Selenelion location at all. Selenelion location is when it is in direct alignment, when it's blood moon. And that's why those images that you see online, where it shows, you know, the refracted angle and it shows a moon off in the distance, the moon is red in those pictures because that is Selenelion. Everything else is just some form of partial eclipse. They don't get the Selenelion badge. They don't get the award for being in the right position at the right time. So hopefully this whole picture has made plenty of sense. So I'm not going to go over it again, but if anyone needs any further questions, I will keep it, and I'll answer people's questions if they do come back with it. All right, there you go, Selenelion Eclipse.